In this example, we're going to take a look at the set of continuous functions on the interval from 0 to 1. And we're going to define an inner product on there as being the inner product of f and g will be the definite integral from 0 to 1 of f of x times g of x dx. We're going to let f of x be equal to the function x, and we're going to let g of x be equal to the function x squared. So with that in mind, let's find a couple things. First thing I'd like to do is find the distance between these two functions. Now, as a reminder, the distance between two functions is defined as the norm of the difference of these two vectors. So first thing we would need to point out is what f of x minus g of x is going to be equal to. F of x minus g of x is going to be x minus x squared. To find the norm, we're going to be multiplying this thing by itself, integrating from 0 to 1, and taking a square root of the result. So the norm of x minus x squared is going to be equal to the square root of the definite integral from 0 to 1 of this function multiplied by itself. Now, if at any point in this process you wanted to, say, leave off a couple of the algebraic operations and simply do one of the things that's on the inside, that's probably for the best. So with that in mind, since I've already got it all copied down, we're going to commit to it. So first thing we'll do is distribute, or FOIL as it were, to come up with x squared minus 2x cubed plus x to the 4th power dx. Each of these can be integrated using the power rule. Doing so will produce 1/3 x cubed minus 1/2 x to the 4th plus 1/5 x to the 5th. This is going to go from 0 to 1. Now, plugging in our x equals 1 is simply going to give us the coefficients, and plugging in x equals 0 will zero everything else out. So this will give us 1/3 minus 1/2 plus 1/5. Getting a lowest common denominator of 30, 1/3 would be 10, 1/2 would be 15, and 1/5 would be 6. That numerator is going to simplify to be 1, and so the distance between these two functions is going to be 1 over the square root of 30. Now, since we've done it for the other examples in here, let's go ahead and find the angle between these two functions as well. So find the angle between these functions. Now for that, we're going to need the inner product of these two functions, as well as the magnitudes of these two functions. So again, the formula goes, cosine of theta is going to be equal to the inner product of f and g divided by the magnitude of f times the magnitude of g. Starting with the inner product of the two functions, according to the definition above, we are supposed to take the definite integral from 0 to 1 of the product of these two functions. Well, x times x squared is going to give us the definite integral from 0 to 1 of x cubed dx. According to the fundamental theorem of calculus, that'll be 1/4 x to the 4th going from 0 to 1. And plugging in these bounds, the upper bound will give us 1/4 and the lower bound will give us 0. So the inner product will be 1/4. And as far as magnitudes are concerned, the magnitude of f is going to be equal to the square root of the definite integral from 0 to 1 of f times f. That'll be x times x dx. So again, the square root of the definite integral from 0 to 1 of x squared dx. Taking this definite integral, we'll get 1/3 x cubed going from 0 to 1, which will give us the square root of 1/3, or 1 over the square root of 3. If we do the same thing for the function g, most of the process is going to look basically the same. I'll make sure we're on camera. There we go. So 0 to 1 of g times g. G times g, however, is going to be x squared times x squared dx. So definite integral from 0 to 1 will be x to the 4th dx. Fundamental theorem of calculus, antiderivative of x to the 4th will be 1/5 x to the 5th, going from 0 to 1. And we'll wind up with a square root of 1/5, which simplifies to be simply 1 over the square root of 5. Taking these three pieces of information and tossing them back into the cosine formula, we are going to get the following. Let's go ahead and flip over to the other side. Nice fresh surface here. This will be the cosine of theta is equal to the inner product of f and g divided by the product of the magnitudes. So 1 over the square root of 3 times 1 over the square root of 5. This whole debacle will simplify into the square root of 15 divided by 4. So for a final answer for this one, we can take the arc cosine of the square root of 15 divided by 4. And since we've done it for our other examples as well, let's go ahead and go to the calculator with this one. It's looking like this is going to be a nice small acute angle to the tune of about 14.48 degrees. Nice.